Before we begin today, I'm delighted to announce that today's video is brought to you by Dashlane. If you've been watching this channel for a while now and you do not know who Jeranism is, then what have you been watching? But seriously, here's a reminder.
If he's holding it up at 23 feet high and we're seeing the light, well, that's because the Earth's curved. So I should only be able to see it when it's at 17 feet. Okay, go ahead and drive down there, Enrique. You're going to hold the light there. Enrique, how high is your light?
17 feet.
I mean, it's as, we don't see you, Enrique. Lift up your light way above your head. Interesting.
Yes, that was Jeran proving curvature when he was trying not to in the Netflix documentary Behind the Curve. Interestingly, Jeranism is still a flat earther after that faux pas, and he's still churning out content. We need to go back and re-evaluate his channel. This is going to be a good one. Hello all and welcome along to another episode of Flat Earth Friday with me, Simon Dan. Thank you very much for joining me. Yes, today we're taking a look at Flat Earth legend Jeran and his channel Jeranism. He has made a video asking whether or not we are spinning. It's an old argument from the Flat Earthers, but let's see if he brings anything new to the table.
First, whenever we're discussing this topic, many people will want to use angular speed.
And why wouldn't you? Angular speed, or angular velocity, refers to how fast something revolves or rotates. Earth revolves.
A 15-degree-per-hour drift.
Thanks, Bob. So yeah.
Why? Well, because the angular speed is the same no matter where you might be on Earth.
And what is the problem with that?
While linear speed is simply distance over time. So we can make this simple with this simple circle animation. Consider first this circle is a merry-go-round with a circumference of 100 feet. Now clearly, to anyone who can just think at all, the blue dot, and we can pretend these are horses since this is a merry-go-round, the blue horse moves faster over a given time. The green horse moves the slowest because of the equation distance over time. The blue horse is going around 100 feet in, say, 4 seconds, but the green horse, which has a much smaller circumference, is going only 10 feet in that same 4 seconds.
Yes, and magically the green horse is moving through the same degree of angle as the blue horse, isn't it?
But if we use angular speed, well then both the green horse and the blue horse have the same angular speed, but very different linear speeds. The blue horse is going 25 feet per second, and the green horse is going 2.5 feet per second, 10 times less. This makes sense. Someone at the center of the merry-go-round will definitely feel a different speed than someone at the edge.
And that makes sense because you need to move faster on the outside to achieve the same angular velocity. I'm not sure what this is proving, Jeran.
However, if we use angular speed, as most globe proponents will want to do, then the speed of the horses is all the same. They're all moving the same angular speed. The blue horse on the outer edge and the green horse towards the middle. So it makes sense why they want to use radians and talk about angular velocity because they would be the same. But we know someone at the outer edge of the merry-go-round would always move faster than someone near the middle.
But we are a rotating object. Why would we use linear speed?
The next little trick that globe believers use is to say, well, yes, we are spinning 1,000 miles per hour at the equator, but we're only going around once per day. No one could ever feel that. Well, in a sense, they're most certainly correct.
Yes, they are. And I'm hoping there won't be a but.
On our merry-go-round here, if the blue dot moved around at, say, 1 rotation per day, you wouldn't even know it was moving. It would be so slow.
Exactly, Jeran. You're getting it now.
But here's the trick. Remember, this merry-go-round is only 100 feet in circumference. So let's extend that to, say, a mile. So now the merry-go-round goes around 1 mile per day. Now, would the blue horse know that it was moving? Well, just barely. Not quite like grass growing, but if you looked out, you would be able to tell that you were moving, but it would be very, very slow. You'd be moving at about 1/25th of a mile per hour. But to see if we'd notice flying 1,000 miles per hour at the equator, we'd have to take that small speed we were just talking about, that 1 mile per day, and multiply it by 25,000. Think of anything moving at any noticeable speed, and then think times 25,000. It's ridiculous.
Yeah, see, you're combining angular velocity and linear speed with that statement. 1 revolution per day is 1 revolution per day. It doesn't matter about the size of the circle.
Think of seeing a car drive by at 30 miles per hour. Okay, well, 25,000 times that is 750,000 miles per hour. Ridiculous. So think of a car going 1 mile per hour. Now times 25,000, that's 25,000 miles per hour. So I hope you can see how insane it is to multiply any speed by 25,000.
Yes, I can, but your calculation to get 25,000 is completely wrong.
But that's what we need to do to compare it to the speed that we're moving on the Earth. That merry-go-round at 1 rotation per day, which is 1 mile per day, needs to be multiplied by 25,000. The speed would send anyone flying off the Earth without a doubt. Let's get back to our example and how it compares to Earth. But my hope is that you realize why I think angular velocity is just not needed here and why globe believers will jump to use it. They want to use angular speed because they want to say that both the blue dot or the gray dot, the red dot, and even the green dot are all going the same speed.
No, we use it because we are rotating.
A 15-degree-per-hour drift.
Thanks again, Bob. Not going in a straight line.
Angular speed lets them do that. Linear speed does not.
Because we are not moving in a straight line.
So linear speed says that the horse on the outside has the greatest linear speed because obviously it has a greater radius. And angular speed says the speed of all the horses is the same because they all make 1 revolution in the same time. Okay, moving on to a globe Earth, since we know linear speed is simply distance over time, we can easily figure out the linear speed for any location on a globe Earth. The circumference of their latitude, which would be d, over time of rotation, 24 hours, which would be t. So, at the equator, we have a circumference of 24,901 miles. We divide that by 24, and we get its linear speed of 1,037 miles per hour. For Los Angeles, we get a circumference at that latitude of 20,670 miles. Divide that by 24, and we get a linear speed of 861 miles per hour. For Anchorage, Alaska, a circumference at that latitude is 12,000 miles. Divide by 24, and we get 500 miles per hour. Move to the tip of Greenland, circumference of 2,771 miles. Divide that by 24, we get 115 miles per hour. And at just outside the North Pole, a circumference of 86 miles. Divide that by 24, and we get about 3.5 miles per hour.
Thank you for showing us all that you can use a calculator, Jeran, but is this relevant?
And again, with linear speed, this is very easy, right? The equator, 24,901 divided by 24 is 1037. Alaska, 12,000 miles circumference, 24 hours equals 500 miles per hour.
Newton's first law states that an object at rest or an object going at constant speed will remain so unless acted upon by an outside force. So essentially, going at a constant speed is very similar to being at rest. You cannot detect it. It doesn't matter if you're going 1 mile an hour or 100,000 miles an hour. If that speed is constant, you will not feel it.
Very easy. But now let's look at angular speed. So the equation for angular speed is velocity equals the angular speed times the radius. So 1037 miles per hour equals the angular speed times the radius, 3959. So the angular speed equals 0.26 radians per hour. So now let's look at the angular speed of Alaska. Again, V equals WR. So that's 500 miles per hour equals W times the radius of 1910. So W equals 0.26 radians per hour.
Does that not seem weird to you? Does that not make you think, oh, hang on, we are rotating?
A 15-degree-per-hour drift.
Geez, Bob, really going for the MVP today, aren't you?
So now you can see that the math is what allows it. The equation for angular speed, no matter where you choose on Earth, is always 0.26 radians per hour. And if you see here, if you go to this site, this little conversion tool, and put in 0.26 radians per hour, what does that equal? Well, it equals 0.999 rotations or revolutions per day. So now you can see how they always want to discuss this topic with angular speed, because linear speed exposes the nonsense.
Right, so linear speed exposes the nonsense of angular speed on a rotating object, which is what you use angular speed for. Gotcha.
Because angular speed says that all horses anywhere on a merry-go-round are all moving the same speed. And get this, that's no matter how big the merry-go-round is. That's crazy talk. Think if a merry-go-round was 1 million miles in circumference. To think that all the horses on the merry-go-round would move at equal speed is kind of loony. Imagine being on an inner horse, then be taken to an outer horse near the edge. Wow.
Well, unless the merry-go-round sped up or slowed down, then you wouldn't notice.
And so, they want us to think that no matter where you are on a merry-go-round, it would always feel the same. That's truly insanity. The difference in speed would be clearly measurable, and yet it's not. It's all mathematics again. We already heard Vsauce tell us that math is not science because we invented it. In math, we decide what's true. Numbers are not even things. They aren't concrete. They are not even nouns. They are adjectives that describe things. No different than colors, really. You cannot show me green any more than you can show me 5.
Actually, I can. This is green, and this is 5. Jeran moves on to another one of his amazing points.
And we can find more of the quote-unquote tricks of the trade. Centrifugal force is the moving or tending to move away from the center, versus centripetal force, which is the moving or tending to move towards a center. If you forget which is which, like I did for a while, an easy way to remember is to think of the F and the P. When I see the F, I think of flying off or flying away, and when I see the P, I think of pulling towards the center. So maybe that will help you a little as well.
So, a man who is trying to tell his audience about physics and maths has to use the letters in the words centrifugal and centripetal in order to remember which one is which. Right. Okay.
Now watch the trick here. The formula for centrifugal force is the centrifugal force equals the mass times the velocity squared over the radius. And the answer is in newtons. And the formula for the centripetal force is force equals mass times the velocity squared over the radius. And the answer is in newtons. Wait, aren't they the same? One for the force flying out and away, and then the other is the force pulling inward? Then you might see that in the general theory of relativity, that it just so happens that gravity and the centrifugal force are equivalent. In order for something to stay still while on a spinning platform like a merry-go-round, they say that all the forces need to add up to a zero vector. Well, to do that, you need the fly-away force to equal the pulling-in force. So when you include our weight, which they say is because of gravity, then you can start to see the mathematical tricks involved. Your senses go right out the window. Really, Jeran, doesn't science require our sense of observation and depend on our senses?
He's about to say our senses are better than physics, isn't he? Nope, I can't continue. I am absolutely shocked, even now, at the absolute disdain that Jeran has for maths and physics. He believes that we are subjectively using science and maths like a crowbar to twist the narrative about Earth and prove flat earthers wrong. But physics is an objective discipline. It is what it is. It works, and it has done for hundreds of years. Anyone who listens to Jeran regarding maths and science need to take a long, hard look at themselves, because I can absolutely assure you he is talking poppycock. Now, Jeran had a hard time understanding Earth's spin, but if he understood it like Dashlane understands online security, then he'd be a globe earther again in no time. Yes, Dashlane are once again sponsoring today's video, the awesome password manager that helps make your online experience faster, easier, and most importantly, safer on all of your devices. Dashlane will generate super strong passwords for any new accounts that you sign up for online, as well as autofill on web pages with personal data such as your address and payment information. The absolute best thing about Dashlane is they will keep all your online passwords and information safe and secure and decrypted in a little online digital vault on all your devices. You just need one master password to unlock everything. Dashlane is trusted by over 11 million users in 180 countries. So get it free on your first device today by going to dashlane.com/SimonDan, and if it does everything I've just said it does, which it will, then use the code SimonDan at the checkout to get 10% off Dashlane Premium. So that brings us nicely to the end of today's Flat Earth Friday. Thank you very much for watching. I do hope you enjoyed it. If you did, a like and subscribe would be thoroughly appreciated. I've been Simon Dan. Have yourselves a great weekend, and I'll see you on Tuesday for part 2 of Taboo Conspiracy's Lunar Lander video. See you then.